It's been a long time since I solved the last problem. Today, I'm gonna solve some medium level question. Let me open the window. Okay, so this time I'm gonna try to solve binary tree right side view. Let's set the timer. Start the timer from 40 minutes. Binary tree right side view. So this is 9.8k likes. So pretty good question, I guess. And then the acceptance rate is 61, so reasonably difficult. Okay, let me read the question. Given the root of binary tree, imagine yourself standing on the right side of the root. Return the value of the node you can see ordered from top of the bottom. What? Return the values of the nodes you can see ordered from top of the bottom. What does that mean? You're standing on the right side of it. Return the values from the nodes. Say the ordered. What? One, two, three, null, 5, 4, 1, 3, 4, 1, 3, 4. Return the values of the nodes you can see ordered from top to bottom. Imagine yourself standing on the right side of it. Right side. I don't understand the question. Standing right side, not in the standing right tree. And then return the values of the nodes you can see ordered from top to bottom, from here to here. So 1, 3, 4. What if we have another one in here? Then can I see? Or right side, not in here, I'm sitting in here. Yeah, I understand now. And then everything is on the 2D surface. So what I can see is the tree is in the right side. But what I'm thinking is that, let's say that there are some trees like this, and then like this, and then I see this, and this, right? Or if there's some tree like this, then tree like this, I think what I see is this one and this one and this one, right? So which means that so what I'm thinking right now is that, well, you can, see these steps and get the last one, and then see these steps and get the last one. Last may not be very good wording, but if we traverse this on the breadth first way, normally what we can do is that we can push this and then pop this and then look at this one and then push again and look at this one and then push again, something like that. But in here what we can do is that this guy can push this first and then this and pop this and then see whether it has the left side. If it has the left side, we can push. Oh, so in this case, so in this case, this guy can push both. Since this can be handled by this one, push both, and then at the same depth, we can pop, and then see whether it has the right side. If it has the right side, we can push that, and then we can also push the left side. Anyways, we have to return this, and then yeah, something like that. So so what it can do is that, but in case of if we have a case like this, and we push this and then pop that, push and then push, and then we push this and then push this, then we have to pop, and then we have to know the current depth. So what I'm thinking is that when you push, we have to memorize the depth. I wonder whether we can solve this in depth first way, so we can traverse from right. So let's move to here. I'm starting from here. There's a right side, so let's move to here, then move to here. And then in some case, we have something like this. So in this case, push, we have this one and this one, it does not have back, and then go into here and then go into here. But when you traverse this, for example, we have node like this. If we have a node like this, then we need to know whether we already have this at this level. So go here, resolve the 0, 1, 2, and then back, and then back, and then here we already have 0, 2, and then we can move to here, and there is no node, so we can return this. We can add this into the list, and then we can go back and traverse to the right. C3, and then C. Yeah, probably we can solve this with depth first way. Let's solve this in depth first way. DFS way. So here what we need to push is the first two. We have to push the node, and then we need to let's this, and then need another. Let me call this array, because not array. We don't know the depth, so let's use that visited, right? So which means that this is depth. So depth has answer. So depth, and then visited. Then we can push. We can pass 0 as a real depth, and then yeah, something like this, and then we can return answer. So inside the DFS, node into depth, and then vector int answer. We want to send it to reference, not to copy a lot of times, and then this is visited, something like this. So first thing we can do is that is whether we let's pass this as an ordered set, because in case of vector, we have to maintain the size, so it is kind of difficult. So let's do this. So if we have visited, so at the first level here, or some level in here, if visited is, if this depth is not in the visited, then we can push. But this is very important. What is very important is that the traversal is in order, which means that node, and then right, and then left. So this one first, and then this one, and then this one, right? This is not in order, pre-order, traversing order is this one. So if visited has depth, then you're gonna just the right side, call the right, move to the right side. And so if node right side, then what it can do is DFS, and then depth +1, the answer, and then visited. Likewise, we'll go to the left. And then here, visited, here, node can be null. Can node be null? I mean, so in here, the number of the node in the tree can be 0. So which means that if node is null, what should we do? There's nothing to do. We can just return, right? And if visited like this, well, like this. Else, well, this is the first node that was visited, and then in the case we can push the answer. So push back node val, and then we can keep to the next level like this, and then insert depth like this. So there's nothing to do when it is already visited. If it is not visited, we can do this. So after all, we can traverse everything. So the time complexity is O of n, and then space complexity for this is this one plus this one. So this one is depth. Space needs for the depth. So in worst case, when there is all the node skewed on the left or right side, that it could be O of n. So and in that case, this answer is also O of n. So in worst case, we can say the space complexity is O of n. So let's try to find out whether this works. So we can make some kind of test case whether to see if this works. So first, empty. So in case of empty, I think we can check this before creating all of this. So like this, and then okay, so this will work. Nothing will be returned, or some base case whether there is only root. So in the case node is not null, then node root. It is not null, so it will be entered into here. Depth count is 0, so we'll enter the root node, and then depth will be entered, and there's no left or right node, so it will be returned. So we'll return root node only. The next thing, like this. This is like this in case whether this and only this and this exist, right? So let's try to copy. So let's say that this is 0 and 1. No, 1 and 3. So this is 1 and this is 3. So in this case, 3 is entered, so 1 is added into the n's. So we have n's and visited, so 1 is added, and then depth 0 is added. And then it has the right node, so it will go into the right node with the depth 1. Then depth 1 is not in here, so 3 will be added into it, and depth 1 is also added into here, and then it does not have any node, so this will be just returned. So finally we'll have 1 3, and then in this case let's consider some complex case, something like this. So here 1 3 will be added, and then this one will be visited, so this one will be added in here, and then depth for this is marked into the visit, and then here this line will be executed, so this one will be visited with the DFS, and then this one is already there, so we will call this to line. So this one will call, this will be passed to the DFS again. So this one now the depth is 0. Count is 0, so this one will be added, and then these steps will be marked into the fidgeted, and then it will return, and then inside the DFS with the root node, this line will be called, and in here, since depth is already handled, it will just go to the child node. This one is same, go to the child node, and this one will fidget here. So this one will be added, right? So we'll get 1, 3, and this one, and this one, and this one. So I think that's it. So let's try to run. Compile error, always compile error. Line 39. Oh, this one is void. Can you not pass one of the? I think we need this, right? We need this. And should we pass this? Well, we have to return this node val somewhere. So if we return here, then this guy will also return the value. So so if this return 3, and then the current node is 2, and we have to return 2, 3. So we need to make a vector with 2, 3, which needs some kind of shift, since we have to push the current node to the front, and then that will make some kind of overhead. So I think this approach will be okay. So it's accepted, and also yeah, but the thing is the speed is pretty bad. Not pretty, because 11.6, I'm on the 12.4, and then space complexity, this is something like 8, and there are someone who does not use any oh, this is runtime. This is very fast one, almost 0. I'm using a bit of memory. Let's run this again, because sometimes when I run again it becomes faster. Yeah. So yeah, I think this will be fine. But I guess we have to consider some case whether we don't use any of the memory. So let's just think about that. Let me just think about that. So one way is, well, we need this, right? So there is no way to remove this. But can we remove this? This is the question, because so one way up to, in this case, one way up to, if we keep this one way to remove this is we can have some kind of bit vector. I don't know how deep this is. Oh, you know what? Instead of doing this, you can just call int deepest int visited, meaning that if we push value into push value node, I mean this val into us, and the depth of the biggest depth of node is k. This is k, right? So here we have int visited instead of set, right? So we can do this like this. So so if visited is greater than depth, less so current depth should be so we haven't visited anything, so we can give this the lowest value. So instead of visited, we have the visited. So if depth is larger, then we can, do this like this. Insert, depth. Okay, now it seems better. Let's try one more time. Good, very good. Very good, 199%. Okay, so I guess this is the answer. So I studied, it took me 27 minutes. It's kind of reasonable, I guess. I should solve this faster. I spent some time while I start at the beginning of this problem because I didn't understand the meaning of the right side. Maybe if there is someone sitting in here, maybe it will be better to understand the right side of it. Let me read this again. Given the root of binary tree, imagine yourself standing on the right side of the tree. Right side of the tree. Right side of it. It is kind of ambiguous. I thought this is node or root node, but it is a tree. So so let's finish this, and I'll try one more tonight. Now, one of the weak thing in my case is that when I encounter a problem that is not very familiar with me, it took me some time to figure the solution out, and in the case when I study alone, I mean not in the interview, when I study, I tend to think, instead of speaking out loud. And I'm used to the kind of thinking in silent atmosphere, but that's not good for the real interview situation. And sometimes last time when I encounter was that when I see the problem, I have no idea how to solve that. And then the problem has so many corner cases, and then the intention of the interviewer is not to solve the question completely, but to see me to approach the problem in structured way. But I started to, become nervous since I'm used to thinking in silent environment. But in the interview, I have to, speak out loud to express what's inside my brain. Then that was not very unusual thing to me at the time. So, and then I started to become kind of nervous. And then one of the things I remember is that I copied some buffer to another buffer by looping element one by one. But the interviewer told me that why don't you use memcopy? So I said, wow, memcopy is better. But in real life, in my previous life, I have rarely used memcopy actually, because I was in the deep learning implementation, and then deep learning, inside the deep learning there are not many things to do memcopy. We have to copy one by one. Mainly because the moment we copy a tensor to another is when we need some kind of conversion, like dimension change or rounding float to int, and then copy the int into the new buffer. So memcopy actually didn't work in most cases in deep learning. So I forgot to use memcopy. Well, definitely there is some source and destination address and then the size, right? But I forgot. And then the thing I didn't use memcopy, that thing actually make me a bit of nervous. Memcopy. Yeah. So next time when the interviewer asks me why don't you use memcopy, then I have to be, wow, what is this? Size of? This is operator? So next time when I encounter same situation where I should not be nervous. That I should be, wow, I should say like, wow, that is a good idea. That does not, and then not using memcopy does not show me that I don't know that situation. Yeah, it showed me that situation, but I should not be nervous. That is a good idea. That is a good idea. Yeah, I could say that is a good idea. That is good. Also, memcopy probably require two elements, which is source and dest, and then size, right? And then is the order correct? Source dest, so from to. No, it's wrong. So yeah, such a thing. So in the case, yeah, so here's always confusing. I should say, everything in very cheerful way. Yeah, everything always is very confusing. Yeah, let's write it like this, something like that, and then I can continue. Yeah, dest first. Memcopy. Dest source. depth source. Yeah, just like L value operation. Above depth equals source, right? So next time I'll try to select a little bit more difficult question and then try to solve that, okay? And then try to speak out loud while I think inside my brain. Okay, see you tonight. Bye.